This week, I'm joined by my crew again for another episode of the Journal Club. We talked about the paper Human Level Control Through Deep Reinforcement Learning. So this is one of the papers that I guess it's pretty well known. Insane amount of citations. It's a seminal paper in the reinforcement learning field. It introduces the use of deep reinforcement learning to create an agent that can play multiple different kinds of games. So, this is a lot of the stuff that underlies things like AlphaGo and everything else, all those interesting things you've seen probably online. Also, I wanted to make a few corrections. In there, I say that when I was a little kid, I used to do something like reward hacking, which is basically I would take an instruction I was given and find the way to do it in the most literal way possible so that, I technically did what I had to do. I think I did some of that, but I don't think I did it enough to be like, okay, I was hacking this system somehow. But anyway, there's that. And I also mentioned that one of the papers that we're going to read next time has 7,000 citations, but that was wrong. The author had 7,000 citations. The paper had far fewer, but just wanted to correct those. Anyways, if you're interested in reinforcement learning, we talk about this paper to not that much detail, but reasonable detail, but we go off on a bunch of tangents and had a great conversation about how to learn and reality and the general rules we all live by and etc. It's an awesome conversation. I hope you enjoy it. I hope you learn something. This is a One Deeper podcast, and catch you again soon. All right, boys. Welcome to the another episode here. Journal Club number 2.
Hello, everyone.
I think this whole thing having to move the mics around, it's actually kind of nice because that kind of means that we won't talk over each other. So one of the things about having a podcast with people have those monitors on with the headphones on is so that it sort of makes it so that you're not recording or you're not talking over other people. But anyway, yeah. So you gotta just point and wave the mic over to you.
So I think I heard exactly the same comments said by Lex during Joe Rogan's podcast, where Joe Rogan was like, "Oh yeah, everyone has the headphones, they have their own set," and Lex was like, "No, we I don't have it that way, so people are forced to take turns." Yeah. Even though I think it wasn't intentional by design, I think it just kind of happened for him, and he decided to never change it. Okay. So we're kind of in the same situation now, which is kind of cool.
Yeah. Well, here we are. All right, so we're going to talk about a lot of things probably, but
AGI, baby.
Yeah, AGI. The paper was the reinforcement learning paper. Was it? It's got a fancy title.
Human Level Control Through Deep Reinforcement Learning.
Yes, that's the one.
Very badass.
Very badass. Okay, I think since Andre's the one who fucking suggested this, I think you should be the one to say something about it first, at least.
Thank you.
Take your time, no pressure, baby.
I got my thesis about this, so I better know my shit. A lot of pressure, boys. A lot of pressure.
Maybe just what is reinforcement learning, bro? For people who are just casuals.
Okay. For the casuals, what we got there? We got supervised learning. As the great Lex Friedman once put it, learning from example. Those are the labels. You get the data. They are labeled. Okay, this is a cat, this is a dog, this is how a cat looks like, this is how a dog looks like. Now, reinforcement learning. What is special about about reinforcement learning, boys?
Yeah, watch for the spring. Don't thing and don't bang on the tables too much.
Is that what's special about reinforcement learning? Is that you learn from experience. No one has to hold your hand. So that's powerful in situations in which learning by example is not really possible. You have a robot, you have a robot, you want it to make a backflip. You can't backflip in front of that robot. So it will learn how to do a backflip.
Can I be mean?
Yes, you can.
How about imitation learning? You can, motion capture a backflip or something like that.
That falls under reinforcement learning.
Does it?
Let's check it out, man. We have laptops in front of us.
That's interesting. I like the choice of example that you made, though. Like, you didn't go for the example from the paper. You went for a random one, and you made it hard for yourself. I appreciate the the self-imposed challenge.
That's how we grow, boys. That's how we go.
Indeed. But yeah, you might be correct about that. It would be nice if you can check it. What I wanted to say, though, is I think the reinforcement learning becomes really useful when you have an environment where there are explicit rewards. For the backflip example, you don't really have, unless you give it one, you don't have an explicit reward halfway through. You completed a backflip, but the intermediate steps are really hard to reward for. While in the paper where we read this month, we have video games from the Atari 2600 console, where you have a lot of steps, right? Like, you have a lot of steps where the agent can learn what the expected reward is for that. But yeah, that was a little sidetrack. Did you find out?
Not just the steps for the reward, right? Like, the agent sort of doesn't even know what the game is to begin with. Like, it has no idea what the Atari thing is. It has no idea what. So if you take the, what is it, like Pong or whatever it is, right? It has no idea what the game, what the paddles are, what the ball is, or any of this is. So it just learns everything straight from just the raw images, from one frame to the next, right? So a ball is in one position, then the next frame it's in another position, and then just from that it's able to. This is a really interesting thing, because, like, okay, the question is, does it actually know? To a certain degree, the answer to this question is that it doesn't matter. But the question is, does it actually know what it's doing? Is it playing the game, right? But from a purely mechanistic point of view, it doesn't matter, and it's not built to do that. It's just built to do. It's just built to make the pixels do a certain thing, right? Which is still really powerful.
Okay, and that's a really interesting thought, which we should definitely get into later. But I think before we do that, let's think about what you just said. And it's the fact that it's using these raw pixels from a screen and learns from itself how to play a game according to some rewards.
Not just a game it's never seen. It has no idea what it is. It doesn't even know. It doesn't even understand the concept of a game. To be honest, right?
And that's what's so groundbreaking about this paper, right? It was released in 2015. And what they did, so it's from Google DeepMind, right? Yeah. And what they did that's so groundbreaking is that they combined reinforcement learning, which is, it's already existed for a while, with deep neural networks, and created deep reinforcement learning.
So, like, one of the big things lately, like, that have been making these things even more impactful, even with, like, ChatGPT, is the fact that we are now able to scale and run and build these massive models, right? And even if some of the ideas had been around for decades, maybe, they just weren't useful until we could do the engineering and build the stuff and, have these massive data centers and build 100-something billion parameter models, which is, interesting. But yeah, so
I think actually, like, as you said, like, the computational power has been a limitation for a long time, and lately it's gotten better. Let's say it's still very expensive, but we can do things that were impossible even 10 years ago, which leads me to the question. This paper has been released almost 10 years ago. What if we took the same architecture and ran it again? How much better would it be? Because they did say they did encounter problems with computational power where they couldn't do hyperparameter optimization pretty much at all, because it was too expensive to run for them. And I'm curious, what will happen if we did it now? How much better would it be? I assume it's not going to be, order of magnitude better, but 10 years of computer, hardware development is almost one order of magnitude better.
I mean, they have games that they've crushed games like
AlphaZero.
Like for sure it's gotten way better. Dota, dude, there's that bot beat a bunch of pro players casually, right? I mean,
I meant like literally the same experiment with the same, the exact same thing. How much better would it get? Like purely based on that computational difference. But yeah, of course, then they had architectural improvements as well that made it so we can crush like humans on pretty much every game, not just Atari, very simple games.
I do want to shout out to Tilburg University for T-SNE. Did you guys notice the T-SNE plot in there? So T-SNE was built by so this nice little the multicolored graph at the bottom, right?
Yeah.
Showing the regions of activation. So that T-SNE was developed by a former Tilburg PhD student.
Seriously?
Yeah.
Nice.
Yeah.
Tilburg University doing big things out there. Changing the game.
Man, I was so happy to see that. I was like, damn, good job.
Okay, I have a question. Yeah. Can we go into one of the things that they did to get these deep neural networks working with the reinforcement learning? Because a common problem within this approach has been that there are weird correlations between like the current state of the agent and the target state of an agent. Because, if it gets close to its final goal, then it's hard to distinguish what the differences are between these two. And one of the ways they avoided this is what they call experience replay, which is extremely computationally expensive. And what they do is that they take the state of the agent, so just a frame of where it currently is, they save this in a huge data set of all of the states that agents has ever been in. And when they train the deep neural network, they randomly sample states from this huge collection of previous states to add some kind of variation into the learning. And they do this because they think that in the human brain, we're doing the same thing. We're replaying memories when we're sleeping, when we're tired, when we're just not thinking about things. And they think that this has an effect on the action value function that they build.
Just to clarify, did you properly understand the difference between that replay training versus the normal training of going through all the data? Because I have to admit, I was a little bit fuzzy on the details. Like, you have normally, like when you do epochs on, any neural network, you usually go through all the data all the time, right? But this replay, was it happening during the training at the end of an epoch? Was it happening throughout? Like that was the only epoch they had, or was it something they do at the end on top of that? Did you?
Yeah,
get
I'm not
this
sure
detail?
where in the training exactly they do it, but what they do, from what I understood, is that they take, in normal training, you have a sequence of states and actions, right? And they're what should I say, like it's in order of the correct states and actions. So one state follows from one action, and that state follows from another action. What they do with experience replay is that they take random states that don't make sense. Like if you would look at the states one after another, they wouldn't make sense. They're all over the place. And that's the point, that you have these random states thrown into the training that they sample uniformly from this huge data collection of all of the previous steps.
Yeah, that's pretty great, actually. I found it very interesting how they proposed this as a solution, which, apparently works really well, to the problem of decoupling states that are near each other from the rewards that they offer, right? Like, you don't necessarily need to do this series of steps to get that reward. It's just one of those steps that led you to the eventual reward, so you can drop the rest. And it is, the random sampling from the replay memory allows you to do just that, to decouple the rewards from, like, to try to figure out what actually caused you to achieve the reward, which would be otherwise a problem.
So this is a real problem, right? Even in the brain, I think it was for a long time people were trying to figure out how exactly it is that we attribute success to actions, right? Because in our daily lives, when we go about doing stuff, we do so many things, right? And when we, let's say, we reach a state that we perceive as a reward or getting somewhere, how we work back from the current state through all the previous states that we experienced and properly attribute a, let's say, positive reward for all the things that helped us get here, That's a real problem, and that's hypothesized that dopamine and acetylcholine play a part in this, right? So what it does is acetylcholine marks the things that you should pay attention to, and then dopamine goes in and reinforces them. But this problem of correctly attributing the things that led to your current state, that's a real problem. Like, it's not just a problem in AI, it's just a problem in figuring out in our brain, like, okay, what the hell is happening, right? So one interesting study that they did was they trained mice to learn the mazes, all right? And while they were learning it, they had electrodes in their brain measuring their firing rate and all this stuff. And when the mouse was done learning the maze, they let the mouse go to sleep, right? And they continued to watch the brain do its thing. And at first it looked like just a bunch of noise, and they were like, okay, well, it's just noisy. But when they slowed it down, what they found was a really strong match between what was being played at like multiple X speed and what was actually happening when the mouse was running through the maze. So while they were sleeping, they were replaying that experience at like at a pace. It's really interesting. It's like, it seems like when you're sleeping, your brain sort of can go into this state where it's not concerned with much of the outside experience, but it's just processing all the experience you had and then just rebuilding stuff, like, okay, learn this, learn that. Like, it's pretty interesting how our brain does it.
It's absolutely fascinating. And I think that's exactly what they were trying to recreate with this experience replay in their algorithms, right? That they replay these memories in a way to try and optimize and tweak the queue function that we should also talk about.
Yeah, exactly. I was about to say we should talk about the queue function and like what it actually is and what it means.
Before we jump to that, I just wanted to add something about the, a problem of coupling or decoupling rewards from what actually caused them. Just wanted to mention like a small fun fact. Pigeons are so bad at this that if you give them a clock, you feed them at a regular interval, and there's like a button or something that they can press, or any type of cue that they might think leads to the rewards, but the reward is actually at a regular interval. They'll keep doing that a lot. It's called like pigeon superstition, and like it happens like if the first time they get fed, they were doing, I don't know, they were spinning on one side, they were just doing one full turn or 2 turns on the other side or something silly like that, it's very likely that they will believe that that's what caused the food to appear. They don't realize it was just like random time intervals or regular time intervals. It's just like, and they will keep doing that over and over and over, hoping that it will lead to another behavior, to another reward. So it's not only a problem in neural networks or artificial neural networks. It's also a problem that some animals haven't solved yet.
Yeah, that's right. We don't even think about a lot of this stuff, but our ability to say like, okay, this action led, like our ability to attribute action to a current state, or like our causal relationship, our ability to map things to causes to results. That's no joke. That's pretty impressive as far as processing goes. But that's cool about the pigeons, though. That's interesting. Anyways, okay. This queue function. Okay. First of all, why is it called queue? Does anybody know? I bet you don't.
I have no idea, actually. That's a great question.
I was about to Google that, but then I ran out of time to review the paper. But please enlighten us.
So Q stands for quality, right? So what is the quality of this action given this state you're in? So there's the action value function, and then there's the state value function, if I'm not mistaken. So basically, the action value function is you have a set of policies, right? Pi, and so from a given state, you take a given action based on the rules of a given policy, right? So it's like if your policy is, if there's food in the fridge, I'm going to eat it, right? And you open the thing, You open the fridge. State is that there is food in the fridge. Action is going to be, so I mean, obviously if it's fully deterministic, then it's just like if then, right? But generally the policy is like a distribution. It's like, okay, with some probability I'll take this action, some probability I'll take this action. And the all of this is defined in terms of how each action and the associated reward does it maximize or minimize the sum of maximum rewards that you can get, right? It's such a it's not a crazy, like it's not, there's nothing like that insane about the concept. It's just like implementation details obviously are tricky, but I think we should also talk about the discount factor. But
Yeah, a question on that. So the idea is that you have this queue function, and it tells you which action is the best to take given a state. And the entire learning process is about finding this policy that will give you the best action given a state. So you have to learn that.
Yep, exactly.
And that's what the agent does by itself.
Exactly.
I will just make a note because this is something that might be a misconception, might lead to a misconception. Like the whole training happens on the assigning values to actions. There's no in other deep learning models, like you train a network to choose, like to do something pretty much. Here you're not training the network to do something. Here you're training the network to evaluate outcomes, and then you pick one pseudo randomly. Like you usually pick the best one, but as they say in the test results, 5% of the times they will pick a random one to just have some chance of exploring other paths, but usually picks the best one. So the policy of the action picking policy is actually not trained. It's handcrafted. It's just like 95% of the times do what you think is best. But it's the thinking what's best that is where the training happens and where the Q learning algorithm applies.
Yeah, and this is called the off-policy Q learning. And that I think that's common for all Q learning, but I'm not sure. But I do know that the model they used is off-policy, which means that when they train the Q learning, they strive for the optimal policy. And they try to take the greedy action. So they try to take the best action to maximize current reward. But when the network is actually playing, they add this exploration feature that you're talking about to let it try new things, to discover new actions, and end up in states that it hasn't been in before. Because maybe those states turns out to be better because it doesn't know. It has to explore.
Yeah, the epsilon function, I think it's called, the exploration, it stands for exploration, is during the training, the first million frames of training, out of 50 million total, I believe, they start with 1 as the parameter for how much they go on exploration, which means at the start it will do completely random moves, which is pretty normal. It hasn't been trained yet. And over time, over these first million frames, it will go down to 0.01, I believe, where it almost always follows the best course of action, except that 1% of the time. And it will keep doing that for the remaining 49 million frames. So it starts very exploratory, and then it just does what it thinks it best and keeps looking for minimal optimizations, with just basically what amounts to a small learning rate. Because, it's a small exploration rate, but I maybe naively want to think that it leads to a similar outcome. But then, in practice, when you do use the algorithm, you let it be a bit more exploratory just to see what happens, at least in this paper.
For me, more than anything else, the interesting thing about AI is, okay, this stuff is cool. Getting machines to do this stuff is cool, but it really helps me think about life and what and how the universe that we exist might be structured, right? Like, so if we can train a machine to do something in this way, or like if this is a reasonable way to think about it so that a machine can do it, right? What does that tell us about the lives that we have? And what does that tell us about the brains that we have? And what kind of insight does that give, right? So, for example, when I think about like when I think about reinforcement learning, like one of the most interesting things for me is the discount factor, right? So discounting future rewards, right?
What does that mean?
So when you're calculating the expected value of a given action in a given state, right? You're basically summing over a bunch of future possible rewards, right? So like, okay, if I'm at this state and I do this action, which takes me to another state which gives me another action. Each of those states has and actions have an associated reward, right? And you're summing over all those rewards. But this is such a really the link here between life and like psychology and computation is so nice, because the discount factor thing is not something that's new in AI or anything like that. They use it a lot in finance as well, right? So you discount future possibility of future income, because the implicit understanding here is that the future is uncertain, right? And the farther out that you look, the more uncertain it is, right? So if you have a really, let's say, okay, so the discount factor, gamma in this paper, right, is between 0 and 1, right? So what happens is, if you have a number that's very close to 1, right, let's say it's 0.99 or whatever, right? Then you multiply. So every time you want to calculate the total reward in the future, you're multiplying gamma by gamma by gamma by gamma by gamma by gamma to however many steps in the future, right? And whenever you multiply two small numbers together, you get an even smaller number, right? Okay. So if gamma is close to 1, that means the rate at which the value of future rewards decay is relatively slow compared to if you had gamma close to 0. That means you are actually fairly certain about what's going to happen in the future in a certain in the way you value rewards. So it's like, if your gamma value is really small, it's more of a get what you can get now sort of situation, right? It's like you're very certain about things that happen at the immediate next time step, but you're way less certain about the things that will happen down the road. So you weight those rewards much less. So basically you're saying things that I can get right now are way more valuable than things that might or might not happen in the future. Okay. So why I bring this up is there's an interesting parallel with psychology.
Can I say something? Yeah, before we move on to that. They actually used 0.99 as the discount factor throughout the training of this algorithm. So they really do value future rewards, and that might be because the Atari games are quite deterministic, at least some of them. While playing something like Dota or chess or AlphaGo is much harder, because you have an opponent and you just can't know what they're going to do in the future. You can predict what they're going to do, but you can't be certain about it.
Yeah, for sure. So this is interesting thing, right? So I think you guys will find this interesting. Human beings discounting of the future is variable, okay? And it changes based on how the environment you grew up in, your current situation, all these weird things happen to you. So, for example, there's this theory called what the hell was it called, Andre? Life history theory, right? So basically, I don't know how this is psychology, so that's a grain of salt. But still, if you grew up in a situation where resources were not dependable, and people like, you couldn't count on the future manifesting the way when you expected it, you value you have a very, very low discount factor, right? So you take things as when they can, when you get them, right? When they're available, and you don't think that much about the future, because like, what the hell, this shit's not gonna happen. Like, people are gonna leave me, or like this, I'm gonna get robbed, or whatever the fuck it is called, right? So there's this really interesting parallel between. I love the idea of a discount factor. It's so interesting. But anyway, so I like how they applied this in a very nice, simple mathematical way to this learning algorithm. It's like, okay, the value of your future rewards is like that simple concept grabs the idea of an uncertain future. Like that's nuts to me. Like just like the fact that you put this little thing in here. Oh yeah, future counted for. Like what? How many lifetimes would it take when you come up with that shit? But like, I mean, you've been doing it for a while, but yeah.
I mean, in layman's terms, they say a bird in the hand is worth two in the bush, right?
Yeah.
It's like, how much do you value like immediate rewards versus long-term rewards? And that's a really important thing for humans. Some of us are better at it than others. Better at actually might be a improper way of saying this, but arguably preferring long-term rewards can lead to greater outcomes.
Okay, now that's true. But that brings us to this important little thing that they do where they randomly sample and they do random exploration, right? That's neat because if you're over optimized in one thing and you're like trying to get the most out of thing is the question is, have I hit a local maximum or local minimum, right? That I can't escape from. Okay, so I'll give you a real life example. Okay, so when before I joined this program, I was working in Sri Lanka, right? I was working for a really big company. Okay, I was an executive doing marketing stuff, right? And if I just stayed there, I have no doubt in my mind. I was just like, I would have risen up the ranks, got the thing, been like, it would have been awesome. But I realized this is a local maximum, right? Like, I was like, okay, I cannot get stuck on this hill. Like, I mean, obviously I didn't have the terminology to think about it that way then, but I was like thinking like, if I stay here and optimize on this thing, there's only so far I can go. I recognize that. And then I just did basically a random restart, right? Like a random search, like a stochastic gradient descent basically, right? And I was like, I just like went on a different direction and explored in hopes of finding a higher ceiling, which I found, right? Luckily. But that could have been catastrophic, right? That could have ended really poorly. So that was a huge risk on my part, right? I left everything. I was like, I quit my job by left everything, right? But it worked out. But it couldn't have worked out. It could have been a complete disaster. But on average, if a bunch of people do that, on average, someone would benefit, right? So it's interesting. But like the parallels here, I love this shit. It's like, this is how I think about this stuff. So it's pretty cool.
I just quickly want to say that talking about life and life choices, life goals in terms of local minimas and maximas is just amazing. I think that's a very rational way to approach life.
Yeah, no, because once it's really weird, right? Once you have this language, it's hard to not use hard not to think of them in this way, right? So like, for example,
R squared values.
Yeah.
I think about life in R squared values.
Exactly.
So when I see something, I'm like, whoa, what's the R squared of that thing?
So it's like, okay, so for example, like I don't like it helps me not take things personally. Like when when I say something, right? And I have a social interaction with someone, right? And they respond to something I say or do in a way that I don't expect, right? I know I shouldn't take that personally because it's a noisy signal, right? Like there are too many weighted sums of things happening, and too many nonlinear functions involved. Like, this person could have just woken up this morning with a bad night's sleep, or like ran out of coffee, and then like all these things happen, and then I say something, and then the person reacts, and it's like completely unexpected. It's like, okay, well, how much should I weight this experience? Like, should I weight what I just saw really highly? Or should I be like, nah, this might be noise, so I'm going to weight it less and weight my past experience more. So I look back over the past interactions with this person, and I think, okay, over the past 10 interactions, this has been not the situation. So I'm gonna disregard this noise, this random occurrence as noise, right? Like same thing, like when you're in the gym. So if you have a plan, like so if I'm doing powerlifting, right? I have a plan of the weight I want to hit next week, right? Sometimes I go in the gym, I want to hit, the goal is to hit 5 reps of a certain weight, right? I only get 4. So I have to think to myself, okay, is this signal or noise? Like, because it could just be I had a bad night's sleep, or I didn't have eaten enough yesterday, or like could be anything. Should I go back and restart the program, the cycle, or should I just move on to the next week and chalk it up to an anomaly, right? So like not significant, like below 0.05. Right? And then like it's such a, I don't know, it's like a nice systematic way of thinking about things. I like really like it. It really makes me happy.
So we've been here for 42 minutes. Wait, have we? I actually don't know when we started.
I have no idea.
Okay, whatever. We've been here for a while, and I actually have a burning question for Andre to start off with. But then I would like anyone to pick up on this. And it's the fact that this paper is heavily inspired by neuroscience. They have multiple parallels between the hippocampal replay of memories. They use convolutional neural networks because they think that's how the early visual cortex works. And this was released 8 years ago. So I'm thinking, what's coming for us in the future with reinforcement learning if we keep learning more about the brain, about how we process information, and if we start applying this in computers?
Thank you, Dennis, for getting me back in the game. I had a semi-existential crisis. I misremembered imitation learning as being part of reinforcement learning, where indeed, Guido, it's supervised learning. You learn by example in imitation learning.
That's good to know, but we will not keep you accountable for that.
No,
That was nice. That was not signal.
It will go down in history, recorded forever.
Yeah, no.
Future directions.
I'll take it out of the. take it out of production.
Out. Nice. Okay. Future directions. Dude, reinforcement learning is the best shot we have.
Bring close to your mouth. Yeah, keep going.
Okay.
Best chance we have what?
Best chance we have. To do cooler and unformalizable and more complex stuff with AI. Like
Speak into the mic, bro.
human in the loop reinforcement learning, dude. That's the best thing there is. Because you can't define reward functions. Because you got reward hacking.
Could you
we also
just describe what human in the loop is for people who are just listening?
Back to the backflip robot that started it all. Well, backflip. How do you make a robot do a backflip? How do you quantify a reward function for doing a backflip? Because you got to have increments. You got to get close to it. It's got to be a gradient. You can't accidentally do a backflip if you're just born on this planet.
That's true.
Like maybe a giraffe, they can
I
run and walk.
don't think
straight.
giraffes can do backflips, buddy. But
They're close. They're
What?
closest there is, man. They're pretty good after they're born. They can do a lot of shit.
your point is taken.
My point still stands. So you can't do a backflip straight after getting born. You gotta be nudged in a certain direction. But how on God's green earth would you put in computational terms doing a backflip and encouraging a backflipping direction?
Okay, hold on. I'm gonna stop you for a second. Okay, this is something that's really, I think, crucial. You touched upon something really important in AI. It's like things that interest me is that like questions like what is a backflip, right? How the fuck do I tell this thing what a backflip is? If you want to train a neural network to recognize dogs, it forces you to ask yourself, what is a dog? right? Like, what am I seeing? Like, what is it that I'm actually seeing, right? Because if I'm trying to put it in a machine, I have to have some functional idea of what is. I need to. I don't. No. I need an operational definition, an operational idea of what the fuck needs to happen for me to see, right? And that's kind of stuff that's super interesting.
And this is one of the reasons AI is such a great mirror reflection of ourselves, because defining these algorithms and how to do a backflip. So let's say, Andre, let's say I tell you that, let's say I'm the reward function. And I'll say that, hey, I want you to learn a backflip. So I'm going to reward you if you rotate over your back axis, basically. What could go wrong with that?
I mean, I think it's a valid approach. Like you make a reward function, like you punish it if it touches the floor with the head or something like that, so it knows it fell. But also you reward it for as much rotation as it gets on the x-axis, let's say, like around the hips. It might work.
I can tell you what I would start doing. I would start doing back rolls.
Yeah, probably. But that's why I added the clause of not hitting the head on the floor.
Yeah, I just put my head to the side, roll over my shoulder.
Yeah, you have to see.
So this nicely brings us into reward hacking, right?
Yeah.
So, man, like, that's the thing, right? Like, so if you actually, if you go on YouTube, you can see this reward hacking example. It's like, so you can see. This is like, so how do you properly define the reward function, right? And this is so true for me in life as well. But no, let's keep this to just like as a computational thing. So for example, there's a game where it's like the video is on YouTube. It's about like racing boats, right? If you just type reward hacking on YouTube, you'll see it. But you tell the algorithm, I want you to collect all the points, maximum number of points, right? And it just learns that if it just circles this one spot over and over again, it can collect the number of points, and it completely disregards the winning of the match, winning of the race, right? So you have to be very careful about what your reward function is. And like, I think that's really helpful. Even like, so if you're like raising kids, it's like, be very careful about what you tell them. Like, I used to be that kind of asshole. Like my dad would like tell me offhand, like, okay, if you do ABC, I'll do this for you. And then I'll go off and find the laziest, most like roundabout way of just doing precisely what he said, right? And show him, look, what you told me to do. He's like, you son of a bitch. Like, that's but what he says is like, that's not what I meant, right? So the computer has no ability to decipher what you meant, right? This is something that comes back all the way even to like programming, just writing average like random normal Python programs, right? So when I was TAing, people would ask me, like, they would say something's wrong, and my immediate response is like, nothing's wrong. It's doing exactly what you told it to do. It's just not doing what you meant it to do, because it has no capability of understanding what you meant, right? And that transfers all the way to this thing as well. If you tell it, you better be precise about it, right? But the fact that they came up with something that's general enough to learn across multiple things, that's pretty impressive. So the reward formalization that they came up with was robust enough to deal with a bunch of different scenarios.
Yeah. So this gets into model complexity, because if you hard code the reward function, if you write it yourself, let's take Space Invaders. Okay, the ball, the frames make it seem like the ball is coming to the left side. You should move to the left. The ball moves kind of to the right. You should move to the right. But what happens when it's close to the wall? Okay, when it's close to the wall, then you should get a little back to the left again. And the thing is, it turns into an expert system if you want to hardcode a reward function for a complex task. It turns into a 200-line if-else statement algorithm that defeats the purpose. Like, you need a lot of experts to understand the reward, to understand what makes an engine successful as a task, and you need a lot of time to figure it out. And the agent, the algorithm, finds a lot of roundabouts, reward hacking.
So this is it. So I'll give you. This is brilliant. Okay. So, one of the things about living is that you want to come up with generalizable algorithms, right? That you can live by. Okay. So now you mentioned something. I had the thought it's just like evaporate. I should have written it down as you were speaking, but. What did you say? You were saying about
model complexity.
Model complexity, and if you just have at the end you'll have just a bunch of if-else statements if you're not general enough, right? Oh, okay, I got it. I remember now. Okay, so when you teach a little kid, right, to play a game, at least when I was taught to play a game, right, one of the things you tell them is that it's not important that you win or lose. What's important is what's important is to play the game properly or like fairly, right? Okay. So one of the reasons why that's important is that if you play properly, you will get invited to play more games, right? Which by definition increases the chances of you winning, right? That's sort of a meta rule that's better than any of the other if-else rules that you could build in to any one game that generalizes to a bunch of different games that you could learn, right? So in life when I'm thinking about stuff, it's like, okay, how can I generate a functional, general enough rule to live by, right? That is hard. It's really difficult to have those kind of rules, right? But that's super interesting. I have nothing else to say there, but that occurred to me as something pretty interesting.
I want to say there's no such thing as a general rule, because it would be nice if there was. Humans would be rational all the time then, right? If we could find and teach people a general rule on how to optimize life, then everyone would act rationally. But I don't want to say it's a nice thing if we had that, because then you live in a society of robots.
Sorry. So wait, that's a good point. And I think we should also talk a bit about the goal specification, right? So part of the reward function, figuring out the right reward function, is inherently figuring out the right goal. Like what's the right endpoint that we should aim this reinforcement learning machine towards, right? Like I just said, if I said just collect the number of points in this thing, it'll just be like, well, fuck this, I'll fucking collect all the points, right? Interesting is like kids who are more intelligent learn to lie fast earlier than kids. Like there's a correlation between IQ and some shit like that. So I was like, that's interesting, right? Why is that? Why does that matter? Well, I think it's because if you tell that if you specify the wrong reward function for that kid, right, it'll get stuck in a local minimum, or like or worst case, a destructive downward spiral that would take it away from doing something useful, right? This reinforcement learning, this entire field, is probably the most interesting thing to me. Because the parallels between what you can learn about psychology and life and how they try to put this shit in a machine, that shit's great. Like it's just like it's a nice little merging of the two things that I care about.
Today what I'm learning about Udesh is that he really thinks kind of the opposite way I do, because in our program, we're studying cognitive science and artificial intelligence, and the idea is we use one to help the other. So Udesh here seems to think we use AI as a tool to understand cognitive science more than the other way around. For me, it's exactly the opposite. I only care about how the brain works to the extent of how much it's going to help me implement amazing solutions for AI. It's really funny. I noticed this contrast and I appreciate it.
That's pretty cool. I think it's partly because I just don't understand people, and I've always had trouble with this shit, right? And it just helps me to like have this nice formalisms like, oh, this kind of works. But like, obviously it's not, but that's a really interesting point. It's cool though, right?
I mean, it makes for a more interesting conversation. If you all agreed on everything, it wouldn't be that cool, right? But Dennis, what are your thoughts on the current situation? On
I
the
have a
current
lot
topic?
of thoughts. I think it's really interesting to talk about these general rules, because a problem I have with that is, okay, besides that there might not be any general rules for life, is that these things change with time. They depend on the current culture we live in, what our values are, and look at like empires 5,000 years ago. They would behead people, and it would be a reasonable punishment. Nowadays we don't even have death penalty in many countries because we think it's so inhumane. So what's the right thing? Like what's the general rule? Well, it depends on so many factors, and it makes my mind go crazy.
I have an opinion that it might be, too simplistic, but I am very utilitarian, to which, the greater good, it's almost always I would say it's always the most important thing, but also it depends on how you implement in practice your pursuit of this greater good. Like that's, otherwise you end up with things where oppressing minorities and stuff. So I would say the greater good is the most important thing, as long as you do it for everyone, not just for a single population or something like that. With a lot of ifs and buts, but that's my baseline.
The downside of that is every time we've tried to do that, we've ended up with the situation you just mentioned, right? It's like the philosophy is like ends up being, oh, you got to break a few eggs to make an omelet. Like, okay, how many eggs? How many eggs and how big is this omelet, bro? Like, it's getting pretty hectic.
That's a dangerous approach.
See, yeah. So like the reward function that and the goal state that you define for these machines in isolation is hard enough, right? But for a human being, like how do you, like, what are the parameters that you set for a person, man? Like here's my fundamental thinking, right? Human beings are the most intelligent autonomous agent that we have, right? And you actually have direct control over one of those autonomous agents, which is yourself. Okay, I'm not going to go and let's forget about the free will thing. That's not okay. Let's just assume that's the reality. Okay, you are the only agent, technically, really, as far as I'm concerned, you're the only agent that you can do anything about, right? So, if I have this sort of general purpose agent that I can play around with, how do I train this thing to do things that I wanted to do? It's like, dude, I constantly see myself in the third person. It's like I see my experiences as training examples for my brain, right? And I get to, and I'm like, and my job is to bias the training examples in a way that reinforces certain behaviors. So that's how I think. It's like if I'm faced with an option, right, and I have to do something, my thought process is like, okay, is this an example that I want the machine to learn from, right? And I take the opposite if it's not the case. But random digression. But like reinforcement learning, it's. I mean, this is a pretty old paper, actually, no? But I'm not up to date on any of the new shit that's been going on, except Dota, which is pretty fucking nice. But
since we're on random thoughts, maybe the human experiment is a multiple human in the loop reinforcement learning paradigm. First, let me get back to human in the loop. So, look at this backflipping noodle. 1, 2, 3 joints, 3 sticks. This is supposed to make a backflip. Now, what's the state space? Well, the state space is all the possible permutations and combinations of all of these joints. So in a continuous world, like the one we live in, it's an infinite space. Now, the action space is also infinite. The torque you apply to every joint is, and the combinations of possible torques are also beyond computation. You can't check them all. You can't check every state in order to build a Q table for, okay, this is the state, this is the reward you have in this state. Because there are too many to compute. Now, how do we nudge this agent in direction? Because it wouldn't stumble upon a correct state even if we define the perfect reward function. Now we do the following thing. We take two recordings. We take two recordings of this noodle bouncing around, strangling around, trying to do backflips, and we ask a human, okay, rate it. Which one is better as a backflip, the left one or the right one? Now, with this thing, it takes about 2 or 3 hours of one human, 30 minutes. It can take as little as 30 minutes. Yeah, it can take as little as 30 minutes with one human annotator to train this noodle to do a backflip. So, you don't need to know the reward function in order to train this robot to do a backflip. You only need an intuition about what kind of looks like a backflip. You need to know the direction in which to nudge this thing. Now, humanity. Maybe that's what all of us are doing. Our rewards function. Unless you studied morality for a pretty long time, I doubt you have a formalized, you have put into sentences what is the exact thing you want to do in life from today until your death, for every minute, every hour.
Well, first of all, even if you study morality for a long time, that you wouldn't still get that. But I get your point.
Yeah.
I wanted to say for this point, I recently found an AI researcher called David Shapiro who's doing a project called Raven, which is basically his best attempt at doing a general artificial intelligence. It doesn't have to be conscious, it just has to work like one. And I want to read the core principles that he's implementing in his AI, and I think that's something that we could all agree is good, both on a personal human level, but possibly also on a societal level. So, to answer your morality question, like, what are we trying to do actually? And the core purposes of Raven are a set of imperatives. To attempt to reduce suffering, to attempt to increase prosperity, and to attempt to increase understanding. Now, the understanding part is mostly for these specific AIs to increase how much it understands about others and how much others can understand about it. But the two goals of humanity, in my opinion, should be aligned with the other ones, the other points that are said here. To attempt to reduce suffering, and this is before the other one, and to attempt to increase prosperity. So the utilitarian view would be to just maximize prosperity, but that should never come at the expense of increasing suffering. You should always try to reduce suffering first and then increase well-being.
Okay, let's take this thing apart a little bit, right? Let's talk about suffering. Right? Suffering in which time scale, right? Or like acute suffering or general suffering? Because if you just imagine that we didn't know what we were doing yesterday in the gym for 2 hours, right? And we only recorded our physiological reactions, right? If you just looked at them in isolation without any context, you would think we were all about to die. Like our cortisol levels were up, our heart rate was up, adrenaline, like our muscles were getting like ripped physically. Like we were our blood CO2 levels weren't exactly great for like an hour and a half continuously. That's we were suffering in a real sense, right? And the problem with, I mean, these are great. These are like Asimov's laws of robotics, right? In a way, like the same sort of vibe. But we come back to this question of suffering. It's like, okay, you want to minimize suffering. Okay, who's suffering at what time? Okay, for by what degree, for what duration, right? Defined by whom? Defined for whom? Like, these are the kind of things that.
This goes back to human in-the-loop reinforcement learning, because you can't formalize prosperity. You can't put it into numbers. It's always gonna be an incomplete formalization. But when you look at different societies, different cultures, different people, you can evaluate which one of these two is more prosperous or in less suffering.
Good. Okay, that's good. Now, to do that, we have to have a goal that we're trying to achieve, right? Like, if we don't have an end state in mind, right, then anything will do. I love this quote. It's like, if you don't know where you're going, any path will do, right? But like you just said, okay, we recognize that this is a worse backflip than that, right? And if we take suffering, for example, it's like, okay, that's less suffering compared to that, right? And I see what you're getting at, right? That's cool.
Can I add something here?
Yeah.
And it's that prosperity and suffering are no absolute terms. There is no absolute prosperity. There's no absolute suffering. They're all relative to each other. I believe that you cannot have prosperity without having suffering. You can't have suffering without prosperity. So we go to the gym for 2.5 hours yesterday, and we feel like shit. Okay, we're whining in there, our bodies are torn down, we're crying, but afterwards, we feel amazing. Because when I go to the library that day and I sit down to study a subject I don't like, it feels great, because I'm not in suffering anymore. Okay, so the pleasure I got from that is because I was suffering. We are prosperous where we are right now, in this part of the world, in this part of our lives, because we know what other people don't have. And we see our own lives and we say, wow, we're so prosperous. We're living the good life because of all the things we have. But it's only relative to other people.
I agree partially with that. Like, the fact that we enjoy our lives because we're better off than others, I don't agree with that. Because I don't know, if I were ignorant about others, I think I would still enjoy my life because I have a pretty good life.
Yeah. No, I agree. Like, it's like, no, see, again, I'm not a reinforced learned artificial agent, so I get what you mean. Right? Even though like, okay, there's definitely like, I like that perspective because it gives you a sense of gratitude. Like to see, like, you look around and you think, holy shit, the lights are always on. Like, there's always, like, it's always warm. I always have food. I can go to the grocery store and expect there to be food there, right? That's coming from where I'm come from, that's a fucking privilege, like, for sure, right? But it's not like it just fell out of the fucking sky, right? Like, we worked really hard. Like, people toiled and suffered and worked to make their life, to make the future for their children better than what they had for themselves, right? So, like, now imagine building an AGI, okay?
Let's go.
Right. Okay. So I had this really interesting conversation, like the episode that I recorded. So when you build algorithms, right? So like ChatGPT or a tweet bot, a Twitter bot. Okay. So when Microsoft made this Twitter bot called Tay, and they put him out and put this bot out into the Twitter sphere, it immediately became the most horrific racist piece of shit like ever. Okay. All right.
Because it learned from the interactions with other people on Twitter,
so
with online users.
So this is interesting, right? This is an interesting interaction between algorithms, okay? Because the Twitter algorithm and the Twitter recommendation process and the Twitter network. So I did a bunch of research on this, right? I wrote a paper on this. Twitter doesn't optimize for this. Twitter, Facebook, YouTube, it doesn't optimize for the spread of truth. It optimizes for the spread of engagement. Okay? And what's maximally engaging is novelty. Right? Novelty and things that get you upset, gets you angry, gets you sad, whatever it is. Whatever is novel, it gets a reaction, is what gets spread in Twitter. So you have one algorithm that's optimized for doing one thing, trained in a vacuum. It has no idea about anything else. It has no idea about the other world. All it knows are tweets. And all it knows are tweets. All it knows are person's demographics, their history, their usage history. And its only existing purpose is to recommend things, recommend channels and tweets and show ads on Twitter. Okay? You have that algorithm built in a vacuum. Then you have Tay built in a vacuum. Okay? All it was it's just a bot that generates language and says stuff, right? You take these two things who are generated without any information about each other, and you put them together in the wild, and unexpected, absurd things happen, of course, right? So but a cool thing about human beings is that if we think of ourselves as algorithms that are trained, we are sort of dampened by the people around us. Right. So when you're growing up, if you weren't raised by some sociopaths, you were engaged with the community around you. Your family is your direct engagement. Then you have your school friends and all these things sort of dampen down your. I think of society and culture as a distributed way of updating your weights matrix, right? So you're not overly weighing certain attributes of your input, and your weights are damped down by experiences of other people and the interactions around you. Right? That's how I think of people. Right?
I want to pick up on something you said, because this is really, really interesting now. So these algorithms are trained in vacuums, and what they basically do is they maximize the reward, which is attention time, or for Tay, I don't know what the reward could have been, but answer queries in a human-like way and learn from your interactions. But then we have new things, foundational models. Have you heard of it?
No, what are those?
I'm sure that there are more terms for this. But foundational models is the idea that we can train models, huge neural networks, and use them and basically do transfer learning to optimize for specific tasks. So take, for example, Tesla's autopilot. Right? When they built their humanoid robots, they took the same network that we use for the self-driving cars,
and
they put it in the robot. And I'm gonna use this word now, but I'm very careful about this. It understands the world in some sort of sense. It understands that if it takes its hand, its joint, and moves it into this water bottle that's in front of me, it's not gonna go through the water bottle because there's an object there. That's to some degree it understands the world. And the idea of foundational models has also been used in language models, where if you take something that is optimized to have conversations in a human-like way, and you train it on mathematics, you'll see that it starts producing better natural language responses as well. Because the understanding of mathematics or programming gives you something that you can use in the process of rationalizing and reasoning about human languages as well.
What happens if we take a foundational all the foundational models that might exist and turn them into a really big single one? Would it have an intrinsic understanding of intuitive physics, semantics, and all that stuff? Would it be an AGI?
Before ChatGPT became a thing, I wrote a short story, called something, I think it's called God Who Art in Heaven or some shit, right? It's basically like this dystopian future world where there's a moon-sized computer that's orbiting the Earth, right? And it initially started off as the Svalbard seed vault.
Yeah, where they keep
all
of the seeds from all of the world secure
exactly.
in case of like an apocalyptic event.
Exactly.
Yeah.
So initially, the story started out as a information vault of all of humanity's generated knowledge and information. Because in case something catastrophic happened to the Earth, we have this backup in space, right? And so they had this data thing, right? But then they were like, okay, we have all this data. We need a way to query it, right? To get information out of it. So they build an AI model on this information so that they can just ask queries from it, right? And then they build an interface to talk, so people on Earth can just ask it questions, right? This is way before ChatGPT, right? This is like 2 years ago.
They predicted ChatGPT.
Okay, and I was like, so now, right? Like, so people when they have questions like they have issues, and then it was so efficient that like they start doing like giving judges like judgments like on crimes. Everything was done by this one thing, right? So in the story, like people went from being religious nut jobs, right, to not believing anything at all, and then depending on one entity in the sky that they pray to with their phones to give them the answers to all their questions, right? So like, and that thing became the general intelligent agent, even though there was no intelligence. This is what I think is going to happen. It's like, what I think is going to happen is that no one's going to intentionally build intelligence, right? We're just going to build a bunch of shit that's like, man, okay, we need this. Oh, this sucks. We need that. We need this. And then something's going to come together and be like, bloop, blip. Oh shit.
So
AGI.
So what this story is basically saying is that if you have a massive enough collection of information, then from having all of those experiences, should we say, all of that knowledge, you can start deriving a fundamental understanding of the world.
What is understanding? Right?
Yeah,
like,
and that's my problem with this
word.
word.
What is it? Like, what is it? What the fuck does that mean, right?
I have no idea.
We have a functional definition of understanding, which means which sort of means like, can I predict what's going to happen? Right? That's kind of
I sort of know what's going on. I can kind of explain why it's happening.
So like a mathematical understanding that we've developed, right, is it's like a very rigorous form of showing that I understand. It's like if you have a system of equations and you're saying, if I give it this thing, if I give it these inputs, I'm gonna get these outputs. Then it's like that's a very rigid form of in the little microsystem you understand precisely what's gonna happen, right? So, but the universe, of course, is a different place, and we don't have this in-out relationship. I mean, I don't think the universe is deterministic, so I don't think that's possible.
You want to know something that freaks me out about this?
Yeah.
What scares me is that with these foundation models, who are going to be the people who can have these foundation models? Well, it's the biggest companies, right? Google, Meta, Tesla. They're going to build these huge foundation models. What if they become so good that doing any work on AI that doesn't include a foundation model is basically obsolete?
Well, do you really want to go into that? Like how big corporations are a problem and we're getting either monopoly or
I don't think so. I think we're going to skip that part.
Okay, so I gotta say, there is definitely some compute envy going on here, right? Like what I mean by compute envy is that I'm getting this kind of vibe. I'm going to piss off a lot of people right now. But I'm getting this vibe that the academic community, right, is a little bit salty about the fact that they can't build a 160 billion parameter network because they don't have the money, right? Like, I feel you, right? It sucks, but like, fucking relax, man. Like, someone's gonna do it. Might as well be these motherfuckers, right?
Well, no, actually, two things I want to say to that. Like the fact that someone's gonna do it is like, yeah, sure, someone is gonna do it, and the problem about it being these motherfuckers is that they do it only for the money with little to no concern for ethics, right?
Yeah, bro, but like, let's be real. How else are you gonna get people to do anything? Like, everything we've ever done that's, well, okay, the ethics thing is, I'm super torn. I'm really torn. You're right. I'm really torn because like part of me, from the perspective of getting shit done and getting shit to work, the best idea we've ever had was to let people build their own teams, build their own companies out of teams, and let them try a bunch of. Letting people start their own companies and do their own thing is our version of maximizing the potential outcome by randomizing the options we have. Because most companies fail. but some companies don't. But the issue now here is that the winner take all aspect is getting much more serious. Because if you're an AI company, I think this is what Sam Harris goes on about. It's like, if you're an AI company, like what's driving the AI arms race in a sense is like, it's such a winner take all thing that if you're the first to do it, you're the last to do anything. That's it. You've basically demolished everybody else, right? I mean, I'm talking about AGI, which is, of course, I think if you talk to people in our department, they have a lot of thoughts about this whole AGI project. Dr. Spronk doesn't think it's going to happen, but yeah.
I mean, that's exactly the problem, right? Like, it's not... Like, I normally love the idea of capitalism. I usually hate it in practice, but I love the idea where you're
a lot of hate is filling the room right now.
I don't know if the microphone can pick it up, but Udish was criticizing that because I am benefiting from it a lot. But I have to remind, we had to put laws in place to prevent child labor, you know, and that's the type of stuff that I hate about capitalism, that if we didn't have laws, we would have child labor. And what I wanted to say, though, is like, imagine these companies who, if we had no laws, would make kids work, now give them the software equivalent of a nuclear weapon. That's my problem. It's like, it should be decided by everyone how we implement AGI, everyone who could contribute. Because there's a lot of moral considerations and there's a lot of danger implied. So...
True. Okay. First of all, I mean, if I was like 10 years old and they were like, yeah, I'll give you $2 an hour to label some things, I'll be like, yeah, sure, fuck it. But like, okay, point taken. But yeah.
That will really quickly lead to a minimum, to a local minimum or maximum.
Oh, for sure. It's a terrible idea. Don't any future utopian listeners out there, don't do that. But like, what the hell was I gonna say? I don't know how to answer this question. Like, honestly, have no idea. It's like the moral implications of. I mean, first of all, in terms of the rules that we need to have to keep companies from doing terrible things, like that's the rules. It's the same as if you imagine a company as a human being, it's the same thing. Like no one's advocating for anarchy or anarcho-capitalism, right? Like that's fucking horrific as far as I can tell. Because like, you know, the whole, for me, it's a game, right? And a game is defined by its rules, right? Of course, right? But this AI thing is tricky because the impact it could possibly have is way more. I mean, actually, I had this conversation with Chris Emery on Friday. You'll hear it when I upload it today. Exact same thing. He has the same concerns about like the costs and the implications of doing these things. But of course, I'm of the mind like, fuck it, let's do it, bro. Let's see what happens.
I'm on the side of fuck it, we're inherently fucked. So I'm studying cognitive science and AI so I can be on top of the game instead.
That's almost what I was going to say, but not quite. The problem is there's no way to control this. No, there are ways, but let's say the legislation is too slow to keep up with research, pretty much. But what I would like to do, as you were saying, my second point that I didn't end up making earlier, when you were talking about the envy of academics towards big companies, what I want to do is join one of these big companies and lead the team that takes us to AGI, you know?
All right, boys. So 10 years from now, you're gonna see this motherfucker, the same guy who was sitting here and not talking shit about capitalism, will be like at Facebook building Meta.
Looking forward to it.
No, look. It's fine. I wish you all the success, right? Like I genuinely do. Like I genuinely hope that like all of us end up somewhere doing, you know, whatever it is that's
living together.
Whatever it is we find meaningful, right? Whatever it is that's engaging. For me, the most important thing about AI is that it lowers the barrier for entry to doing creative work. Right? Like if you have an idea, I want a short story, I want this story, I want to take this photograph, I want to make this piece of art, right? you can just that's one of the things that I really like about generative models is like it lowers the barrier of entry for doing computer graphics or writing code or whatever it is, right? Like if you're at home, it's like, man, freaking, I just want to build this real thing that turns off the lights at this certain time, right? You don't have to go through an entire 4-year program to learn how to code, do that, right? Just be like, go to ChatGPT, I want to do this thing. It'll say, okay, you need the Arduino, you need this, you need this, and here's the code to do it. Plug it in. Oh, cool. The barrier for entry it reduces the barrier for entry for doing shit yourself, which I think is a big thing. And also, it makes intelligence scalable in the sense that, like, so if you take, for example, diagnosing diabetic retinopathy with from your eyes. If you look at your eyes, you can look at the damage caused to the veins to see, as a function of diabetes, right? That used to take a team of like an expert and a whole clinic and like a whole fucking song and dance to do it. Now, take a photo with your camera phone, upload it to a cloud thing with a computer vision algorithm, and beep boop boop, it'll tell you 99% accuracy whether you have the shit or not. Now, people in Africa who can't even afford a car, let alone go to a clinic, can get their eyes diagnosed by the same guy who gave them their fucking spectacles. Like, that's the ability to take intelligence, turn it into something scalable, and put it up there. That's awesome. But of course, not all these things are open. Like OpenAI is the least open place probably at this point.
Yeah.
Microsoft AI.
But I think what you're talking about is, it's really important, right? And it's an exciting future to bring AI to the people, make it accessible, just like we were talking about before, right? That everyone should have a voice in this.
The reinforcement learning is super interesting because it sort of eliminates it saves us from having to be precise about the things we want. You know what I mean? Because that's really hard. It's super hard to do. Like we said, how the fuck do you define a backflip? It's really hard. But we can get around it by going on Amazon, getting a bunch of people from all over the world, be like, what's the better backflip? This or this, right? Oh yeah, that's good. That's good. And then we can just train this thing to do that. Man. But this is the problem. Our ability to do stuff is outpacing our understanding of how things work. Right?
Interesting thought.
Like with neural networks, it doesn't fucking matter if you understand how this thing works. Just keep throwing layers at it until it does what until it does what it wants you to do, right? Like you don't have to understand shit at this point. That's a real problem. Like so our tools are outstripping our wisdom.
What I imagine is engineers at OpenAI who are like, so we made GPT-2, but I have really no idea on how to continue that now. What do we do? Yeah, let's add 10 times more parameters.
It's like if 160 billion parameters was good, 320 billion is probably better, right? Yeah, let's do it.
So tell me, Udesh, if humanity would be a multi-agent, human-in-the-loop reinforcement learning type of situation, what are we optimizing for?
Oh man, why you ask me that question? I can barely go to sleep at night as it is, bro. Like, you think I understand this fucking problem? Look, my general thinking about life is that it's like a movie that we paid to go into, but the moment we walked in through the door, we forgot why we came here. It's like we paid the cost of existing. I think the cost of existing is paid up front, and that's to suffer. You can't escape that. You define how you want, you're gonna suffer. Like that's like actually like a fundamental Buddhist principle. It's like life is suffering. Okay, so that's the cost of entry, and I think the rest of your life is you have to decide how much you can extract from the cost you just paid. Right, that's it. Like, it's up to you.
Trying to find value on your investments.
Yeah, exactly. It's up to you. You paid the upfront cost. Like, you're born with a death sentence, right? Like, everyone is terminally ill, right? Everyone is terminally ill. We are all that's it, right? So the question is, what can you do to maximize the return on, maximize the expected reward on all of your current states, right? So that's what I think. And as far as to, like, I've been trying to understand what the hell people are doing in my life for a while, man. Because, like, it really helps me to operationalize these things in these terms. It actually calms me down, because otherwise I find people to be way more random than I can handle, right? And for me, it's like, I really think, okay, so for example, Andre, you need to explain what a reference friend is. Reference friend is.
Yes, so a reference friend is one of the many concepts I came up with. I patented even. Well, that's a friend that keeps you grounded. That's a friend that you keep around in your group of friends, because you have a reference. You have a referent to the casuals, to the usual people, to the normal people. You know what normal people are up to by having a reference friend.
Who's that for you?
Udesh.
Wait, you chose Udesh as your stereotypical normal person?
Can I just say, I think that's kind of beautiful, actually.
I think you might have introduced a lot of bias if that's who you think is a normal person.
No, for sure. I think we had this conversation, Andre had this conversation once about the fact that, like, when you're interacting with, so if you think about your life, right, think about the people you interact with, you hang out with people from our department, right? Our professors, your friends all go to university, more or less, right? How many friends do you have that don't go to university, right? I don't know any of them, right? You are in this weird little bubble, right? And it's interesting, fun bubble to be in, of course, but most of the world is not you, dude.
It's extremely unrepresentative of what the world really looks like. Especially as you go up in your level of education. Like in the US, like if you get a PhD, that puts you in the top 1% of people. Because, I mean, in terms of, like, being in a percent of anything, right? I'm not saying you're the best at anything. I'm just saying, like, in the US, I think it's like 1.6% of the people have a PhD of 500 million people, right? So it makes you then you think that the rest of the world is like your friends and your people. That's a fucking joke. Andre and I were in town one time, and we were shocked by this person that we saw. We went to a store, and it looked like it was someone who had, like, a cigarette burn, like, on their face, right? And it was just like, holy shit, right? Because the immediate reaction was, okay, if that is a cigarette burn, no one did that to themselves, right? Someone did that to that person. And then you think, and in that moment, I was like buying supplements and some shit like that. And I thought to myself, holy fuck, my life could be way worse right now, depending on the actions that I could have taken, given depending on the policy I had on a state that I was in and an action that I took, I could have been in a completely different situation, right? So I don't know if that answered your question about life, but, like, I don't know how we got here.
Don't go to the bad part of Tilburg, kids.
Yeah, it's bad. Okay, look. Yeah, anyway. So, man, 90 minutes, boys. Like, it's been wild. Anything, I'm trying to keep this thing for, like, 90 minutes because, like, that's about as much as my juices can handle.
Yeah. I have a last remark and then I'm done speaking.
Yeah.
I think it's been really fascinating to read this paper about reinforcement learning. I think it's a very exciting future field of AI research.
I think you guys went deeper on it than I did. I was like I was so caught up on the discount factor and psychology stuff. I was just like, holy
that was
shit,
also really interesting. Yeah.
But definitely cool.
Yeah, fascinating paper. I'm really happy to be here, and we're talking about people and relations, and this is truly an area where you can challenge your mind and your thinking and push those boundaries. So thank you for that.
No, for sure, man. This has been great. Andre?
Collective cognition, baby. That's how we should brand this podcast.
Dude, this is great. what else? I wanted to say something. Okay, yeah. So the next paper. Ooh. Do you have any ideas?
I have no ideas.
I expected this question coming up, so I was just done typing into ChatGPT. What are the top 5 research papers that about AI that I should read? And the first one that has been recommended is ImageNet classification with deep convolutional neural networks. Would you guys find this interesting?
I had a recommendation that might be a little.
Information theory, isn't it? Shannon.
No, actually, kind of. It's a. I think you guys would like it. Hold on one second. I'm just looking it up. So it's a entropy based conceptualization of understanding anxiety. Yeah. Okay. So the title of the paper is Psychological Entropy, a framework for understanding uncertainty related anxiety. It's got 7,500 citations.
Just from that title, I'm truly intrigued. I think we should read this one.
Wait, how the fuck does this thing have 7,000 citations? That makes no sense. That's a lot. But anyway, let me read you the abstract. Entropy, a concept derived from thermodynamics and information theory, describes the amount of uncertainty and disorder within a system. Self-organizing systems engage in a continual dialogue with the environment and must adapt themselves to changing circumstances to keep internal entropy at a manageable level. We propose the model of uncertainty, EMU. No, we propose the entropy model of uncertainty, EMU, an integrative theoretical framework that applies the idea of entropy to the human information system to understand uncertainty-related anxiety.
Wow. Just wow. That's cool.
Yeah, that might be beyond my pay grade, but I'll try.
Dude, I've been wanting to read this paper for a while, and now I have a good reason to do so. We should do this.
There's just one closing remark that I would like to make. My idea wasn't just to show my idea wasn't so bad. Of the 5 papers that GPT recommended us, 2 of them we already read.
Oh, nice, good job, team. Holy shit, not
Let's
bad.
go.
That's pretty good.
The big God has spoken. ChatGPT agrees with us.
Exactly. God agrees. But okay, cool. I will send you guys this paper. Again, I want to thank you guys for joining me on this. Look, I want you to understand that I appreciate the fact that this is a Monday morning and you have other shit to do right now. And I appreciate you sitting here and just humoring me with this. Because as far as social interaction goes, this is, for me.
This peak.
Yeah, it's what it does. Honestly, it's like working out, hanging out in the gym, and doing stuff like this. This is it satiates my need for social interaction. It's
Lovely.
good.
Thanks for having me.
No, of course, man.
Yeah, thanks for having us.
For sure. All right.
Do you want to go for lunch?
Yeah.
Nah, I got shit to do. All right, boys. Catch you guys next time. Thanks everyone for listening, and I hope you learned something. All right, bye. This has been a One Deeper podcast. Thank you for listening. I hope you learned something, and I'll see you again next time.